Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. We're doing some confidence interval examples. You might have seen the pencast that I put up about how confidence intervals work, but there weren't a ton of examples in there. So let's look at the two possible formulas that we can use that we're going to see on the exam. One that estimates means. This one on the left here is for estimating means. That's x bar plus or minus t times the sample standard deviation over the square root of n. So that's when you're estimating a mean. And the formula on the right in purple is for estimating percentages or proportions. P hat plus or minus z times the square root of p hat times 1 minus p hat over n. So that's for estimating proportions. So those are the two main types of data that we see in Intro to Stat: quantitative, which is means, and qualitative, which is proportions. And we want to estimate both of them using these formulas. Key thing about the formula is that in red here I put in the middle, this t and this z score right here, the book has that little alpha over 2. It's basically the number of standard deviations based on the confidence percent. And we always put that confidence percent is always a middle percent. So when I do that problem, that's going to be most of my work or most of my beginning work is looking at that t or that z based on the confidence percent. I'll put that percent in the middle and then either use inverse t if I'm looking up a t, or you could use the t table for people who have TI-83s, or if I'm looking up a z, I'll use inverse norm, or if you want, you can use the z table, but everybody has the inverse norm function in their calculator. So let's look at a couple examples. Alright, so the first one says we want to estimate the percentage of CCD students who use the light rail. So we decide to sample 175 students and find that 93 used the light rail. So right away, that's our p hat. We know that n is 175, that's how many we sampled, and that 93 is the 93 out of the 175, 93 out of 175. So that's our p hat. Calculate that, and you do, I'm putting my calculator here, 93 divided by 175, and I'll round this to 4 digits, 5314.5314. And then the other main part is that we're using a 99% confidence. Okay, so I need to put 99% confidence in the middle. I'll draw this picture down here. If 99% is in the middle, then that means that we have a 0.5% in each tail, 0.5%. But remember that 0.5% as a decimal is 0.005. So I do inverse norm. And why am I doing inverse norm? Let's go back to the formula. If you notice the formula, I'm using proportions. I have a p hat, so that means I'm looking up a z. This formula tells me that. You're going to have this purple and orange formula on your formula sheet. Once you identify that you're doing a confidence interval, it's one of these two formulas. And then basically, since I've identified that I have a p hat, that means I'm looking up a z. So I'm using inverse norm of 0.005. That's 0.5% as a decimal. So I do second bars inverse norm 0.005, and it'll give me the one on the left, the negative. So I'll just write the plus and minus because I'm using both. The 2.5758. Alright, that's a terrible 8. Okay, let's erase that. 5758. Okay, so then, just following the formula from the last page here, p hat plus or minus z times square root of p hat, 1 minus p hat over n. I have all those numbers, so I'm going to type it in. I don't have enough room to write the formula and then write it again, so I'll just type the numbers in. Or write the numbers in, excuse me. So p hat is 0.5314 times the z, which is 2.5758, times the square root of p hat, which is 0.5314, times 1 minus oops, 1 minus 0.5314, okay, over n, which is 175. Alright, so you type that into your calculator just in the same order. So I do 0.5314 times 2.5758. Or no, sorry. Ooh, I'm making a big mistake. Sorry, this wasn't 0.53, it was plus or minus. Plus or minus right there. Ooh, let me erase that and fix that. I'm sorry, guys. So, plus or minus 2.57. So let me erase my calculator. Okay. 0.5314 plus 2.5758 times second square root of 0.5314 parenthesis 1 minus 0.5314, and that parenthesis divided by 175. I did it all in one line, one more parenthesis, press enter. That gives me the upper bound, UB, of 0.6286, or we can call that 62.86%. And then to get the lower bound, remember we can just press second, enter, and go up and change that plus to a minus, and it'll give me the lower bound of 0.4342, or 43.42%. Now I don't have enough room to write the interpretation. We're not supposed to do this really until the project. You might do it once on the test, but I can say that I'm 99% confident that the true proportion of CCD students who use the light rail is between 43.42 and 68.86%. The other thing that I could say is that, remember, my estimate was 53.14%. If I want to find the margin of error, I could do the 62.86% minus the 53.14%, and that's a 9.72%. So I could say, another way I could say this, you don't need to, but you could say my estimate of the percent that use light rail, I'm 99% confident that it's 53% plus or minus 9.72%. But I'm really okay with you just giving me the lower and upper bound following the formula that way. Okay, so now on to the next example. We want to estimate the average amount of time spent on the internet per week. We survey 70 internet users and find an average of 17.5 hours with a standard deviation of 6.32 hours. Give the 95% confidence interval for the average number of hours per week on the internet. So this is about averages. We've already talked average. We have average here. So we're definitely using the orange formula, x bar plus or minus t times the square t times the standard deviation divided by the square root of n. So we just need to jot down what we have. It says we survey 70 internet users. That tells us n is 70. And find an average of 17.5. Well, that means that x bar is 17.5. Let me fix this 0 here, gosh. N was 70. Gosh, I'm really bad at that. 70, there we go. Okay, and sample standard deviation, because it came from the sample, 6.32. So all I got to do is look up this t-score now. Alright, so it's a 95% confidence. Remember, I'm looking up a t because it says t right there for the mean formula. Put 95% in the middle. This is a lot of people forget this and they just do inverse t of 95%, but they actually have to put 95% in the middle, which means 2.5% in each tail. So we're going to do inverse t of 0.025. And remember, inverse t also wants to know the degrees of freedom. So we need to tell it that the degrees of freedom, remember, is the sample size minus 1. So that's 69. If you were using your table, you would just go down the 0.025 column and go to 60, because the degrees of freedom of 69 is in between 60 and 70. So you would go down to 60, but I'm using inverse t, so I type 0.025 and 69, comma 69, and I get the negative 1.9949. So I'm going to write plus and minus 1.9949. Okay, then I follow my formula. X bar 17.5 plus or minus the 1.9949 times the sample standard deviation, which is 6.32 divided by the square root of n, which is 70. Okay? Sorry, let me redo that. Square root of 70. Look kind of crummy. Square root of 70. Okay. So we just got to type it into our calculator and get the upper bound and the lower bound. So I type 17.5 plus 1.9949 times 6.32 divided by the second square root of 70. I didn't need to do any parentheses on that one. And I get an upper bound of basically 19.0069. So 19.0069. Remember, to get the lower bound, just press second, enter, go up and change that plus to a minus, and it's 15.9931. 15.9931. So, remember, we can say with 95% confidence that the average number of hours spent per week on the internet is basically between 16 hours and 19 hours. Remember, our first estimate was 17.5 hours. If you want to find the margin of error, you could do 19 minus the 17.5, and that's 1.5 hours. So, an easier, the way the news report would say it is that we're 95% confident that the average number of hours spent on the internet is 17.5 plus or minus 1.5 hours. So don't forget about those interpretations for your project. But basically, it's just a matter of once we're asked for a confidence interval, we know we're going to use one of the two formulas, the orange or the purple. You'll have that available to you. You just have to decide whether you have means or proportions. Means, we tell you straight up, you have an average and a standard deviation. So that should be obvious. You just got to remember to look up inverse t. And the big thing that students make mistakes on is that they just do inverse t or inverse norm of the confidence percent. But you have to put the percent in the middle and then look up the percent in the tails so you actually look up the correct t. Pretty important, and good luck with your problems.